Translate the following statements into coordinates and then plot the discrete function. So let's see, we need 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4, 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4. So f of negative 1 equals 1, so that's right here. F of 2 equals 7, so 4, 5, 6, 7. F of 2, go all the way up to 7. F of 1 is negative 1. F of 3 is 0. And f of 2 is negative 1. What is the graph's domain? So the graph's domain would be x equals negative 1, 1, 2, and 3. The graph's range would be y equals negative 1, 0, 1, and 7. Is the graph a function? Explain why or why not. So I noticed that when I input 2, I could have an output of 7 or an output of negative 1. So it's not a function. So x equals 2 has 2 different y values. Y equals 7 and y equals negative 1. Evaluate the following expressions given the functions below. So g of 10 would be negative 3 times 10 plus 1. Negative 30 is negative 29. F of 3, let's see, f is here. That would be 3 squared plus 7. 9 plus 7. So f of 3 equals 16. H of negative 2 would be 12 divided by negative 2, which is negative 6. J of 7 would be 2 times 7 plus 9. 14 plus 9 is 23. H of A means we plug in A for x, so we get 12 over A. Find x if g of x equals 16. So I know that g of x equals 16, so I'm just going to write 16 equals negative 3x plus 1. Subtract 1 from both sides. I get 15 equals negative 3x divided by negative 3. And we get that x equals negative 5. Find x if h of x equals negative 2. So 12 over x equals negative 2. I'm going to multiply both sides by x so that we can cancel out there. So we get 12 equals negative 2x divided by negative 2. And we get negative 6. X equals negative 6. Fill in the chart for each of the following graphs. So here the domain, so x equals, this is x equals, let's see, negative 3, negative 2, 1, and 4. The range, y equals, let's see, negative 4, negative 2, 0, 3, and 5. Is it a function? No. Because right here, this is a problem. X equals 1 has 2 y values. Discrete or continuous? It is discrete because it's a set of points. It's not a line. The points are not connected. Here the domain is, it goes from negative 2, and it's including negative 2, and it's all the way up to positive 2. The range, y goes from 0 to 4. Is it a function? No. Because, for example, x equals 0 has 2 y values. this is a continuous function because it's not just a set of points. It's a line, or it's connected points. For this one, the domain, it goes forever to the left, forever to the right. So the domain is all real numbers. Same with the range, because it goes forever up and forever down. Is it a function? Yes. Each x value has only one y value, and it is continuous. This one, the domain is all real numbers because it goes forever to the right and forever to the left. The range, everything greater than, so y can be anything greater than -5 or equal to. Or you could say that y goes from -5 to infinity. Is it a function? Yes. Each x value only has one y value, and it is continuous. Solve the following equations. Show all your work and graph your solution on a number line. So first thing we're going to do is distribute this -2. So we get x minus 6x minus 8 equals 2 minus 5x. I'm going to combine my like terms here. X minus 6x is -5x. I'm going to add 5x to both sides. I notice that my 5x's cancel out, and I'm left with -8 equals 2. This means that we have no solution, because that's not true. -8 cannot equal 2, so that means no solution. Here I need to undo what I've done to x, so I'm going to subtract 2 to both sides. That will cancel out, and I get 3x over 7 equals 3. Since I'm dividing by 7 here, I'm going to multiply both sides times 7. So the 7's cancel out, and I get 3x equals 21. Divide by 3, x equals 7.